and identify the possible causes is the next step. See, once that problem is been this thing, as a team we will have to involve all the team members. Like if you see, we will not select a team which is only on the production team. See, how to select a team is a key role again in the any problem analysis. For example, as a if you want to work on any problem or any project, team from all the different function has to be involved, in the sense one from production, one from the operation, one from the maintenance, one from the quality, one from the HR. If it is any skill related issue, for that HR needs to be involved. And once a team form, then we will have to ask why it is happened. Like it is a general thumb rule says, if you ask 5 times why for any possible causes, that will drill down into the what is the actual cause of the problem. And the one tool which is very key and the powerful tool for identifying the possible causes is brainstorming. Brainstorming is what it means, is as a group of people all can be gathered at either offline or online process. What do I mainly prefer, and the effective method is in the online process, that is in the collecting the information or analyzing the any problem. When you do at the Gemba, you will be gives a really good output, in the sense that will throw us a good ideas that can generate good ideas when you analyze the problem at the Gemba, that is the where the actually the process is taken place. Example, brainstorming. What is the process involved in the brainstorm is, whatever the team identified all can be assembled, whatever the ideas coming from all of them irrespective of any department, all can be captured. This is, do not neglect any of the ideas coming out from the any of them in the team, and that is a key this thing of the brainstorming. Note down all points from the team, do not criticize anybody, in the sense you what, for example, if one of them says manpower has not come to the this thing, that mainly caused the problem. Because of that we had put on new manpower. You just take that point, because that also could be the final cause of that what the problem is reported from the customer or any problem what you are analyzing. See, in the main thing which we notable thing on the brainstorming analysis is, do not criticize anybody. Whatever the points come out from the team, we need to take, and the whatever the what we are going to see in the subsequent slides will tell us how to eliminate what the unwanted points comes out from the brainstorm. See, the as a team from the different teams can have each own as their own knowledge on their process. So, whatever the points come, it need to be taken, and the next powerful tool is on the how do we got the around let us say 50 numbers of causes for the set problem. How do you stratify into a different process, like means here if you see cause and effect diagram, this is the like stratification of whatever the possible causes what we got from the brainstorming, that can be stratified under 6 categories. One is the man, second is method, and third is measurement, fourth is material, fifth is environment, and see here environment also plays a role, and the last one is the man. See, if you see here why the environmental and measurements are taken, see previously there were only 4M, man, machine, material, method. See, that time the method, measurement and environment are not focused here, because that comes under previously under the special focus being not given for the measurement and environment. Later on many of the problem analyzed and find out that this also could cause the defect generation. So, that later on these 2 M's additionally be introduced in the cause and effect diagram. In some of the companies they call it as a 6M methodology, that is the cause and effect diagram, the different name of some of the other companies they proposed as 6M methodology. Let us talk about one by one case in this this thing. For example, if you see here measurement, it comes under calibration status. If the calibration of the measuring instrument is not done properly, that also can give wrong output. Example, if you see here the what is the problem taken as example here, dimension oversize. Dimension oversize is mean not, it is it comes under some measurement where the dimension of the customer specified is being measured. In the sense, if the calibration is not done properly, when the operator or whoever is measuring in the process, that will give non-conformity data. So, what will happen, as for whoever is measuring, that shows actual, but in reality if the calibration is expired or not done properly, whatever not okay products which is giving us a okay, and whatever the okay products that can also there is a chance wherever the okay product also can give not okay, in that case there will be a huge non-conformance during production. So, that also not good. See, that is the one key thing which we captured here. For the measurement, calibration is very important this thing. And for the material, yes, for any dimension overseas, material also can contribute. For example, they said there are 10 process where there will be one input, one output, one input, one output. Okay. For example, in a machining process, the machine has a set and capability capable to remove only 1 millimeter on the as a thickness. For example, in the step B, the output should be 10 millimeter plus or minus 0.5. Okay, that should be the input for the step 4. Assume if the step 4, the input from step 3 would be 10.5 means 9.10 to 11 is the ideal limit. Example, if the step 4 is getting 11.5, which is 0.5 millimeter higher than the specified limit, what will happen? The set parameter in the step 4 was plus or minus 0.5 only. If the input is more, the machine cannot able to remove the 1.5 millimeter against the 1 millimeter tolerance is being set at the step 4, and fortunately what will happen? The machine can remove only 1 millimeter instead of 10 at the step 3. What will the final the output will be produced 11.5, where the input itself is wrong, the output also obviously it will be wrong only. So, the material also plays a key role in this any this thing problem analyzing. And the third is on the personal, that is the manpower. The man can definitely play a role. For example, if a regular trained manpower is not there, unfortunately the day he has not come, what will happen? Any of these people will swap the next manpower to the critical this thing. For example, if the manpower has not known the what and all things to do and not to do process, if in that particular step 4 or whatever the process, you will do definitely some wrong way, what will happen? That will definitely leads to the rejection. And fourth thing is on the environment. Yes, environment also definitely plays a role. For example, if the measurement or any this thing has to be checked under controlled temperature, that has to be done, because if the temperature of any measurement, what the standard says is it should be under 22 plus or minus 2 degrees centigrade. See, for example, if you check any measurement of the metal parts or any instruments at 30 degree, what will definitely it will give you wrong reading. So, the measurement under environmental condition is a mainly contributing parameters of any measurement related activities. And the fourth is on the methods. Methods means tools, jigs, fixture, what process and what stage, those are all comes under the methods. And machine, when you come to the machine, there are many parameters also contributing on the any output of the machining industries, like machine speed, feed, run rate, speed rate, tool life, everything comes under on the machines. So, on the right hand side if you see, there is a whatever you are focusing on the defects, that is a problem from customer or anything, that is that we call it as effect in the cause and effect diagram, that is a fishbone diagram. So, that can be mentioned on the effect column, and whatever we are talking about these 6 M's, man, matter, material, machine, environment, those are all whatever the possible causes, those are all branched into sub-branched into these 6 category, and those are all the causes called as a causes. So, whatever the causes possible causes comes from the brainstorming, that is plotted on the left hand side of the this 6 categories. On the right hand side we call it as a effect. The next take is on the corrective action. So, once this I will go back to the previous slide, whatever the causes being identified in the cause and effect diagram on points comes out from the brainstorming, those we call it as a possible causes. So, possible causes, the next step is the identify the probable causes. In the sense I told you earlier, there are some 50 this thing points comes out from the brainstorming session, and some of them would be the really actual cause for the to generate that effect, that is a defect, what we call here it as a dimension oversize. So, how do we deselect the remaining unwanted causes? See, what we will have to take is example, if we let us take this calibration, that is calibration status, one of the cause comes from the team was calibration status is not as per the requirement, which means that calibration could be the error for this cause. So, when we go and check the what you have to do here is we will have to check the calibration status of the particular instrument being used for this dimensional oversize problem. So, what you do is we know the problem, what is the part number, when it is being produced, everything we have the data. What we will have to do is we will have to go to the shop floor and see on that set date who is the co-was quality person and what was the instrument being used on that defect, that in the sense for the process of grinding or whatever it may be, where the dimension of oversize being checked. So, we are the cross verification, how the cost being validation here is we will have to see the calibration certificate for the instrument. Let us take here we can take as example of vernier caliper. The vernier caliper is being used for the dimension oversize. What we will have to check here is we will have to check the calibration status of that vernier and see what was the when it was done and when is the calibration due. Is the calibration due date is within the target, I mean within the period, then this cost could not be the problem for that defect. So, we will here it clearly says it is insignificant. So, we can deselect that this is not the cause of the problem. In such a way we need to validate all the causes whatever comes out from the brainstorming session. Like the one more example what we can take is machine speed. Let us take machine one example in the machine. What here the points comes out from that team is high speed, like here there could be a chance because of high speed the material is not removed properly. Okay. So, what we will have to do is we will have to go to the SOP and see what is the speed mentioned in the SOP and see what was the actual which was produced and stored in the system. This data we can see either in the default feeded program or we can see the process data monitoring sheet, like every shift the process critical parameters being monitored in some of the cases, like every shift the autonomous check speed should be this, oil level should be this, machine turning rate should be this. So, we will check the record or sometimes the program it is been automatically saved. So, in this case if you see the machine, for example, if you see the SOP, the machine speed says 1 meter per minute, we will have to see the what is the program feeded data. So, if you see if you observe if it is 1, yes, it is SOP says 1, the actual also is 1. So, this is insignificant. So, such a way we need to validate all the possible causes comes out from the team. Let us take one more example for the from the personnel, that is man. This is training skill. See again if you see the training, we will check the who was produced on that shift and we will take that person name and we will check with the HR whether this person is skilled enough to do the job, whether you have the skill matrix and whether this person being trained in this process or not. So, this will tell us the skill record will tell us all this history of this person being qualified for what and all process. So, in such a way this can be verified. And material, stainless steel, carbon steel, for example, material mix up also can create this issue, in the sense for example, in place of stainless steel if you use carbon steel, the machine parameter is being set for the stainless steel removal rate, but the actual material would be carbon steel, that also can be done. So, what we need to verify is what are the problem reported from the customer, either we will be sending somebody there, check whether the material is correct or not. If possible we will get the sample and give it to the lab and see whether the metallurgical part, whether the material is as per requirement or not, because few of them under stainless steel there would be many categories. One is a major category of stainless steel and carbon steel, and under stainless steel there will be a different category, this percentage of magnesium, silicon kind of thing. So, what we will have to do is we will have to give that material to the laboratory for the further analysis, because by visually you cannot able to identify this kind of defects, whether the change in the material or not. So, once this is been report from the lab, we will have to cross check that with the SOP, that is this says this percent of nickel, this percent of carbon, SOP also says. So, if it is qualifies, then that also can be neglected. So, in such a way we need to validate all the 50 causes and see what is significant. Significant in the sense, example, let us take one more example, method. Method says grinding. Grinding is a method and grinding should be like 1000 RPM per minute. When you validate this cause at the machine, example, if you see the actual process parameter record or the whatever the program, in case of program, the machine parameter is fed as a data of 1150, the SOP says 1000 plus or minus 50, which means that there is a gap between the SOP and the actual production. So, in such a way it clearly says that there is a gap between the SOP and the actual, it is clearly says this is the significant. In such a way we need to validate all the causes and find out what and all the insignificant causes and what are the insignificant causes. Those significant causes are called as root cause. So, out of these brainstorming points, what are the points come on, all things needs to be taken into consideration, all points to be stratified into 6 category, and validation has to be done and find out the what are all the probable root cause. This can be called as another way. Once this probable root cause been find out, so the next step is identifying the corrective action and preventive action for the causes identified. So, what is mean by corrective and preventive action, and the is very key topic to understand what is the difference between corrective action and preventive action. See, assume if there is let us see the example, assume there is a fire at the crates being stored, there is a boxes, wooden corrugated sheet boxes being stored at warehouse. So, the correction is put the fire out at the time, means at the point of time I am eliminating the or vanishing the problem, reported problem. Here in this case the fire is happened, what is the immediate action to be taken? We need to shut off the fire. So, that is the correction. And corrective action, if somebody is poking near that wooden or paper material area, we need to tell them to stop, it should not be done at this area. That is the corrective action, means what caused the fire and how to prevent. In this case, if you see what would have caused the for the fire this thing happened, see somebody has smoked there, and some could have been the thrown away the fire material or this any electrical leak happened. So, what caused the fire and how to prevent the recurrence? Recurrence in the sense that should not happen after that event. So, for that some action we what are the action taking for that is called as a corrective action. And the preventive action is stop fire from the happening, there is a stop the recurrence, in the sense it should not happen again, like a like poke kind of thing. Here if you see, we have put the banner called this is a non-smoking area, and the next can be, we can all this material should be stored under the covered room or fence area where nobody can enter into that premises. So, in the sense what preventive action here for this fire case is stop fire from the happening, that for that what and all action taking. And I want to add one more point here which is away from this topic, that is the ISO 9000, that is the quality management system of the 2015 version which was released on March. What it says is there is no more word of preventive action, because what were earlier we were doing is all these actions, preventive actions or corrective actions, what we are doing here is on the post occurrence of any problem. So, what the new version of standard says is there should not be any this thing of preventive action. In place of that they have introduced a new tool called risk based thinking, that is RBT. Risk based thinking in the sense, as a process, from the process what we have to do is we need to identify what are all the possible risks which can happen in our process. Those risks should be identified, and for all the risks based on our past experience or from the experts, we need to identify the causes and probability, severity, and what are the recommended action if the severe RPN number is greater than 100. Those number has to be fixed based on our business perspective. For example, if you see the automotive industry, it is already the terminology called FMEA. FMEA means failure mode and effect analysis. So, you see the words, it failure mode and effect analysis. Whatever the failure can happen in my process, those can be identified as a failure mode. For could be the effect for these failure modes that need to be analyzed. For the effects, what are all the causes, for that causes the proposed action need to be derived for all these failure modes. In what a failure mode, the other these things are talks about is what, for example, let us take one failure mode of what we are analyzing. This is dimension oversize. The dimension oversize is the failure mode. What causes for the failure mode, which we identified on the cause and effect diagram. Let us take machine speed, that over machine speed is not as per SOP, that is spindle speed is more, that is the cause. And what is the effect for that is rejection at customer end, my customer line stops, this is the effect. See, for this effect, cause and failure mode, we need to derive the probability occurrence detection. Probability means what is the probable condition of this failure mode. There will be rating of 1 to 10, which is 1 is low and 10 is high. We need to rate from 1 to 10 different scale. And next is the severity. How severe is the problem? How severe in the sense, my customer line stops very high, or it can be detected at my place, it is very very low, medium kind of thing. We need to identify the severity conditions. Detection in the sense, again there are some categories low, medium, high. In the sense, what detection means is how much we can able to, or how easily we can able to identify these defects at process or customer end or before dispatch. If it is the customer end, then we will not be having any control at the process, it means like that. So, detection under categories under low, medium, high. Such a way, if you calculate all these 3 numbers RPN, that RPN equal to probability occurrence detection. So, we need to multiply all these things to get the RPN value, and if any, what as general standard what it says is, if the RPN is greater than 100, which is alarming, in the sense we need to take any action to avoid that products which is generating non-conformance and skipping to customer end. So, we need to reduce the RPN number of all the failure modes, and that has to come under below 60 category, which means that if all the RPN numbers of like between 52 and 75 or whatever the RPM less than 80, which means that very very good and we are in the control levels. And the effectiveness. So, once the action being taken and which is implemented, we need to review the results for the corrective action being taken. So, what we need to do is, we will have to modify the corrective actions if you think whatever the action taken is not giving the proper result, that also we can take it as a team, and we will have to try for different approach, and if the bean problem is resolved, so we will have to take a different approach to get the required output. So, how do we analyze the effectiveness of the any action being taken? So, first we will have to monitor the desired output is achieved or not with the action revised action taken. We need to evaluate, and if the report says we have targeted 1% and if the actual is 1.5, let us take as a numbers, if it is greater than the what we targeted. So, what we will have to know is definitely we will have to improve, and we will have to revisit the correction has been taken, whatever taken is in place or there is some gap. So, we need to improve, and we have to again take different action, again monitor, again evaluate, again this cycle has to be repeated until we achieve the desired output. And once this been update, action been taken and monitored for the like short term period of let us take 1 month or kind of thing, and if everything whatever the desired output is being achieved, so we will have to update the revised procedure and the documents. Here what are the documents in the operation or any processing industry? One is the SOP and OPL control plan, and for the drawings if any jigs or change in the design is involved, and all this has to be changed, because if we will have to as a system these all need to be changed, because if any new manpower or any other people who are coming tomorrow to work on the place, they need to know that this is to be followed. If we let us take example, if you have not updated this revised information in the SOPs, assume if tomorrow a new manpower come to that that X station, if the old SOP available in the sense, what you will do, you will just change that new parameter to the old parameter which is already changed in the system, which will take into again the earlier mode of the defect generation mode. So, whatever the changes those all need to be definitely updated in the relevant documents. Some can be can be updated only in the control plane, or some can be updated in both the places. There are many things we need to identify where it is relevant, identify those documents and update in the relevant this thing. Example, in some of the cases drawing may not be applicable, because if there is no change in the machine tools being used or jigs being used, if there is no change in that components, then there will not be any change in the drawings. For example, if you take only there is the root cause for this problem, any problem is if you identify the machine speed as there was some gap in the machine speed, then the drawing won't be applicable. Then the applicable parameters only is on the document, is on the SOPs and this thing. And the other step is on the check and control. Once all this been updated in the documents, we need to monitor the effectiveness of the action being taken for this problem for a period of at least 6 months. If you do not monitor this thing, what will happen over a period of time is, again this will go back to the problem stage that we do not know, because we are the short term monitoring. What we have done was only the period of 3 weeks or 1 month. So, with that time this would have come okay, but we need to monitor whether this is being sustained in the long period. For that, what we have to do is, we will have to monitor this in at least for next 6 months to see whether the results are consistent. If the results are consistent, then it is very good, whatever we updated in the system, that is being followed for the upcoming days. If something major fall or some dip happened in the process result, for example, the first 3 months whatever we targeted for 1% is achieved, and certainly the 4th and 5th month, if the rejection rate is gone to 1.5%, then something problem at that 4th and 5th that we need to analyze. See, for the first 3 months has come okay, if suddenly 4th and 5th is not okay, then something could have happened, either new manpower, again we need to analyze the Gemba analysis and see what would have gone wrong. The monitoring effectiveness is very important for any project completion once the short term is being over. Normally, typically 6 months would be the this minimum 6 months we need to monitor the effectiveness of any action being taken. Then we need to see whether plot into the different whatever the applicable, like a trend chart or whatever the thing we use. That is it on the today's this thing. I think what we have covered majorly on the root cause analysis. One is on the what is root cause, and what are the tools used in the root cause method, and 7 steps of root cause method analysis. And the main key thing, one more thing I want to tell here is, this root cause analysis is not only for the our official or business perspective. This can be applied in anywhere in the business as well as our personal this thing, like brainstorming points, whatever we have discussed here, we discussed today, all are applicable for both our official and personal these things.